Alright, this is lesson 7.5a. This is quite a long one, so we'll just assume that's going to be 7.5a. In intermediate algebra, review of systems of linear equations in two variables. Okay, so one of the things that I need to remind you of what a system of equations are. A system of linear equation means that on one graph, such as right here, we have two equations. The line of one equation does this, the line of the other one does that, and notice they cross at one point. So we have three different options when we're looking at two linear equations and looking for their answers. Their answers are either going to be the same, and we're going to get one solution, and it's going to be where these two lines cross. So that's one solution. The other solution is the two lines are parallel. When you graph the two equations, you get two parallel lines that don't cross at all. That means there's no solution. There's no place that they intersect. So we can't say that our x for the red line and our x for the blue line are going to be the same. See right here, for example, this x right here where they cross, we came over, let's say we came over 2. Well, to get to this point, we came over 2 for the blue line and 2 for the red line. So they share the number of spaces that we come over. And let's say we go up 1. Well, to get to this point, we went up 1 and we're on the blue line and we're on the red line. So the solution sets are the same where they cross. Okay, over here they don't cross at all, so there's no answer. And here we have basically a blue line and a red line on top of each other. And when they're on top of each other like that, every solution along the red line is the same as the solution on the blue line. So that means that there are an infinite number of solutions. Every point on this line here is going to be true or going to make work for the other line. Alright, so they're on top of each other there. Okay, so those are our three options there, and we will get all three of those answers off in different problems that we're doing here. Okay, let me get rid of this funky pink and nasty blue and get some darker colors on here. Alright, we've done the elimination method before. Example 1. 4x plus 3y equals 10. And 2x plus y equals 4. Alright, so we've got those two equations, and they're a system here, meaning that when we draw one equation, the line of one equation, and we draw the other line, hopefully they'll cross somewhere, and that's the answer that we're looking for here, is where they cross. Alright, so let's go ahead and look at this one. And what we're going to do with this is we're going to do elimination. I'm going to erase this here just so I've got a little bit more room. And I'm going to look and find out which I want to eliminate. Do I want to eliminate the x's? Do I want to eliminate the y's? Okay, doesn't matter. It's just one method is easier than the other. If we eliminate the x's, we have to find a common factor here. What does both 4 and 2 go into? Well, 4 goes into 4 and 2 goes into 4. So 4 might work, which means we would multiply this entire thing by 2 so that they're both the same number. In fact, we'd multiply it by -2. So our top number stays the same. Our bottom number changes to -4x minus 2y equals -8. We add those, and we get 0 here. We get 0 x's, so we don't even have to write those. We get positive 3 and a -2. We get a 1y, and that equals 10 minus 8 is 2, so y equals 2. Alright, if, let's say, we wanted to, and I'm going to make my pen a little bit smaller here, I'm going to write the same equation in white, 4x plus 3y equals 10, and 2x plus y equals 4. Now let's say I want to get rid of the y's. So I'm going to multiply. I need, in order for these two numbers to be the same, The top number is already a 3, so I'm good there, but I'm going to multiply the bottom by negative 3. And that gives me 4x plus 3y. The top is unchanged. And the bottom is negative 6x plus, minus 3y equals negative 12. Add those together, negative 2x. Those go away because a positive and a negative of the same number is 0. And that equals negative 2. Divide by negative 2, divide by negative 2, and I've got an x equal any number over itself is 1. So there's my x value, and there's my y value. And at that point, I'm done. Alright, let's look at example number 2. And they start getting a little bit more challenging, not too much, but just a little. Why did I put a negative 2 or a 1 there? And then we've got 2x minus 3y, and we're going to say that equals 1. Alright, so what is the easiest variable to get rid of? The x or the y? Well, I'm thinking the x because two numbers multiply, or the common multiple of this is 6. The common multiple of this is 15, and it's a bigger number. So I usually want to take the common multiple that's the smallest. Again, it doesn't matter which one you use. It's just whether you want your life to be easier or more difficult. So let's multiply this by 2, because then that'll give me a 6 there. And we'll multiply this by negative 3, which will give me a negative 6 there. And I know that a positive 6 and a negative 6 will be 0 when I add them together. So let's distribute the top one. Okay, multiplied 2 by everything. And let's do the bottom one. Okay. Alright. So, whoops, negative 3. Why didn't that show up? Okay. Add those together, I get 0. Add these together, I get negative 1y. Add these together, I get negative 7. And if you remember, if you have a negative y, you can change it to a positive by just changing it and the sign of everything else. In this case, it's just a 7. Alright, so now I've got that. Now all I do is take this number, pick an equation, and plug it in for y. In this case, I put a 7 there. So 2x minus 21 equals 1. Add 21 to both sides. Divide by 2, and I get an 11. So x is 11, and y is 7. And I'm done. Alright, let's look at example number 3 here. And we'll probably have some variation here. Let's see what we've got. 2x minus 3y equals 4. And the other equation is 4x plus 5y equals 3. Alright, so let's go ahead and see what we get here. I think that I would like to get rid of the x's because, again, the common multiple here is 4. So I don't have to do anything to this one because it's 4. And all I have to do is change this one to a 4. So I'm going to multiply that by negative 2. And I get negative 4x plus 6y equals negative 8. So that's my top. And my bottom I'm going to leave the same. Add those together and we'll put our answer in blue. Those go away. 11y equals negative 5. Divide by 11. And y equals negative 5 over 11. Okay, now I just have to find what my x value is since my y is negative 11. Well, I have a couple options here. I can either put negative 5 over 11 in here for y, here or here. Or I can solve this again just like I just did, but instead of getting rid of the x's here, get rid of the y's. Okay, so let's do that. It's not bad to practice that. Either way, you're going to get the same answer. So here is the original problem over again. And in this case, I'm going to get rid of my y's and solve for x. So the common multiple here is 15. So if I multiply that by 5, that'll give me a negative 15. If I multiply this by 3, that'll give me a positive 15, and then they'll cancel. So I get 10x minus 15y equals 20. So what I did, again, is I distributed this 5 to each one of these. Let's do the same on the bottom. 12x plus 15y equals 9. That gives me 22x, those go away, equals 29. X equals 29 over 22. So there's my other answer. Alright, so that wasn't really too difficult. What I'm going to do here is show you the other way of getting the same answer here, but we'll do the other option. We found y, and we found out that y is negative 5 over 11. Well, I'm going to take one of these problems here and substitute that in. Doesn't matter which one. Let's use the 2x minus 3y equals 4. Alright, we know what the y is, so we're going to plug that in. Okay, multiply those together. Yuck. So I'm going to have to find common denominators. I'm going to have to move this up. Okay, so I have 2x equals 44 minus 15 is 29. 29 over 11. Then I'm going to divide both sides by 2. And invert and multiply. And I get x equals 29 over 22, which is the same thing I got for the last problem. Okay, so those are your two options. You can either find one of the variables, take that answer, and plug it in to one of the original problems, like I did here, or do this whole thing over again, but instead of solving for the x, solve for the y, or instead of solving for the y, solve for the x. It doesn't really matter which one you do, but I find that this way that I just did here is more of a chance of making a mistake. So I like to find the x, use an elimination, and then find the y, use an elimination. And that usually works fine. There are some times where you can't do it, but for the most part you shouldn't have any trouble. Alright, so we'll continue with 7.5b as in boy with the next example.